In this video, we will discuss sample preparation for soft materials and cryo-TEM samples. Let's start with the soft materials sample preparation. Today, we are going to use a biological sample. This is a mouse liver. To start the sample preparation, biological samples need to be chemically fixed using formaldehyde. This process of fixing stops the sample from degrading. The sample is soaked in formaldehyde for at least 2 hours. All biological samples that come into our lab are fixed ahead of time. We will then stain the samples with heavy metals. This builds contrast in the samples so we will be able to see the membranes and other things inside the cell. The next step is to dehydrate the samples. We wash it multiple times in ethanol. Each wash is an increasing percentage, starting with 30% and ending with 100% ethanol. Soft material samples are not hard enough to be thin sectioned. So once the 100% ethanol wash is complete, we add an epoxy resin. The samples are left in resin for at least 8 hours. We usually let the sample soak overnight. We remove the sample from the resin and place it into a mold with fresh resin. Next, we bake the sample in an oven for 48 hours to solidify the resin. Here's a prepared sample. Remember that TEM means Transmission Electron Microscope, so that means the electrons pass through the sample to get an image. So the sample must be less than 150 nanometers thick for the electrons to pass through it. We will use a specialized instrument called an ultramicrotome with a diamond knife to make the thin sections of the sample. The microtome works by moving the sample over the diamond knife. The knife has a boat that is filled with water, and after slicing, the thin sections float on the water. The color of the thin section is a cue as to how thick the sample is. For TEM, we want gold-colored sections. I'm going to put the section onto a grid, which we will take to the TEM for imaging. Now I'd like to introduce you to Melanie O'Sullivan. Melanie will be taking us through the cryo-TEM sample prep and the cryo-TEM imaging.
Hi Michelle, let's get started. Before I do anything, I need to put on a mask because my breath can warm up the liquid nitrogen in the sample, and the whole point of cryo-TEM is to keep the sample frozen. First, I'll pour liquid nitrogen into the freezing chamber, which is also called a dewar. We do this to lower the temperature in the dewar so that it will be cold enough to keep the ethane in liquid form. The ethane goes here in the centre vessel. The liquid ethane temperature is between -140 and -180 degrees centigrade. When the Vitrobot plunges the sample into the liquid ethane, the sample freezes very quickly and the Vitrobot holds the sample in the liquid ethane. To start the process, we put the TEM grid onto the Vitrobot tweezers. Then, we load the tweezers into the Vitrobot. Next, using a pipette, we load the liquid sample onto the grid. We have to take out as much water as possible from the sample. This process is called blotting, and we use absorbent paper to remove fluid from the sample. The Vitrobot does this for us, but we need to enter parameters that include drain time, blotting time, and angle of the blotting paper. The Vitrobot immediately plunges the sample into freezing liquid ethane after the blotting process. Now that our sample is frozen in the liquid ethane, we need to take it out of the ethane and transfer it to a grid box. The sample is attached to the tweezers on the Vitrobot, so I'm going to take the tweezers and put the sample into a cold grid box, which is then put into a dewar that has liquid nitrogen in it. We need to keep our sample frozen as we move it to the TEM for imaging. Now let's go to the TEM room and load our sample into the TEM.
Now, let's do some imaging. First, I'll show you how to image a thin section sample with the TEM.
And then I'm going to show you how to image a sample by cryo-TEM.
Here's our thin section sample on the TEM grid. We place the grid onto the sample holder. Remember that the TEM is always under vacuum, so we need to carefully insert the sample holder into the TEM. Then we are going to optimize the beam to get the best images possible. Today, we are imaging a sample of muscle tissue. I am interested in looking at the mitochondria and Z bands in this muscle, so let's search for them. This is our thin-sectioned image of our muscle tissue. This large black area here is our nucleus. These smaller round objects are mitochondria. Notice that the mitochondria don't necessarily look like they do in a textbook. The filamentous areas here, that is your actin and myosin filaments. And the dark black bands are the Z bands in the muscle. Now let's go to Melanie for the cryo-TEM imaging.
Here's our frozen sample in the cold liquid nitrogen dewar. First, we cool off the Cryo-TEM sample holder, then we load the sample into the holder. To do this, we take the grid box out of the liquid nitrogen dewar and put it into the transfer station, which also has liquid nitrogen to keep the sample cold. Then we take the grid out of the grid box and place the TEM grid into the Cryo-TEM sample holder. Then we put the cryo sample holder into the TEM. Then we align the electron beam and go looking around on our sample for a good spot to image. Today we are imaging a sample of polymersomes. Polymersomes are nano-sized biodegradable polymer containers which we can load dyes or drugs into for the imaging and treatment of cancer in patients. Once I've made these polymersomes in the lab, I need to check using Cryo-TEM that they're the correct size for optimal accumulation in tumours.
Thank you for joining us today during the Soft Materials and Cryo-TEM video.